Hi, so good evening, everybody. And great to have you all in this webinar today called Biomechanics and the Secrets of Motion. And before we start with today's webinar, I'll just give a brief introduction about myself. So I'm Gayatri Suresh, and I have done my master's in biomechanics, and I work as a biomechanist. And therefore, I'll be conducting this webinar because I know how difficult this subject tends to be for people in their second year or so. So with this webinar today, my aim is to take you through the introduction or the basics of biomechanics, through which you can then later understand concepts in your exam. You don't have to really sit and learn the biomechanics subject. You can just write based on the concepts that you know. Okay. So since it's a YouTube live, if you have any comments, you can please write it down in the comment section of YouTube and I can answer it later on. Just a minute. Yeah. So today's overview will be about what biomechanics is, what is the subject of biomechanics, how it became a physiotherapy subject, and then why you should even study it in the first place. Then we'll move on to human kinematics and then human kinetics. And then by the end of the webinar, I'll give you a template to write about any joint. So usually when it comes to joint complexes, they're asked for 10 or 15 marks, depending on which university you're in. And it can be quite a long thing to answer. So I'll be giving you a template of how to write that. And then by the end of the webinar, we'll do a small activity of sorts. Yeah. So when it comes to biomechanics, you probably already have a basic idea about what it is. So when you were in school, especially in your 8th, ninth, or 10th standard, you might have learned about the pulley system or the Newton's laws, the 3 Newton's laws, which will be coming back to you here. Or even, the fishing rod or the lever systems, the pulley systems, Newton's laws, etc. So these concepts are also applicable to biomechanics. So since you've learned it in physics, these are the concepts of mechanics. The whole point of learning these concepts is to see how objects move or how motion is occurring in any of these objects. You just add the word bio to it and it becomes biomechanics. That is, these options, so these concepts will be applied to the human body. So then by definition, biomechanics is an interdisciplinary field where you'll apply these principles of physics to biological systems to understand how organisms interact with their surroundings. So basically, you'll just be taking physics and putting it to the human body. That's all biomechanics is. Now, how did it become a physiotherapy subject? So people would not have thought of actually, applying levers to the human body or, applying the Newton's laws to the human body. So the thing is, we live in a time where a lot of knowledge has already been established. You have textbooks, you have video lectures, you have teachers, you have your well-structured syllabus. But when people were trying to research on how the human body moves or works so that they can come up with rehabilitation plans, they realized that there are a lot of similarities. If you can see the picture on left, I'll just switch on my pointer. Yeah. This picture on the left here is of a beam and column, which is one of the fundamental concepts of mechanical engineering. Whereas if you see in the human body, the pelvis and the femur also are in sort of in the shape of a beam and column, which give the lower body stability. If you see on the right here, you have the simple pulley system, which helps you to make it easier to lift a load or so. And if you see on the right here, we have a lot of human pulleys. So in our fingers, with each joint here, we have a pulley system so that all these tendons don't come off or all these tendons are kept in place and function effectively for each of these small finger movements. The most famous anatomical pulley is the patella, which changes the line of the quadriceps. So people started realizing that there are some similarities which they can take from mechanics to be able to better understand human biomechanics. That's why you got this subject, which then became a part of physiotherapy because we learn about movement the most. Now, the difference in this, there is a difference. So you cannot obviously take, if I take the beam column theory, which has one beam and two columns, I cannot apply that concept exactly because human bodies are obviously not machines. So that's the major difference. Humans are not machines. So human tissues, they can grow, they can age, they can heal, they can get injured, and all this happens automatically. Machines do not go through all this. So once a machine is built, it is there. Then injury to a human body can heal. a damage to machines cannot heal. Someone external has to, do something about it. Then machines are usually made of their metals or aluminum or alloys. Human bodies have a variety of tissue, each of them which can interact with each other. So you have blood, which is a different material, you have the bone, which is a different material. So each of these, while being very different, they all come together to make the human body act. So even though we are taking the concepts from mechanics, we should not be simplifying the human body. Like, oh, someone's posture is tilted, therefore they'll have a sequence of abnormalities or sequence of pathologies. The human body doesn't work that way. We'll be constantly adapting. But using the concepts of mechanics, we'll be able to understand movement better. So while you have to keep this in mind. While you take these concepts to learn about the human body, you also have to keep in mind that the human body is much, much more adaptable and strong than any machine will ever be. Then comes the question of why do you have to even study this at all? The main purpose is that we are the profession that deal with movement. So physiotherapists, no matter what field you're interested in, whether it is uh, orthopedics or gynecology or respiratory systems, all of these subspecializations of physiotherapy deal with human movement. That's why we are called human movement therapists also. So physiotherapists are also called movement therapists. And this is applicable to humans and even animals with the concept of veterinary physiotherapy coming up. So when our entire profession revolves around movement, we should be able to solve two essential questions. One is how to manage injury. So when it comes to orthopedics, you'll be dealing with fractures or things like that. When it comes to respiratory conditions, you'll be dealing with things like a puncture to the lung or something like that. Neurological is when someone has one of the neurological systems impaired, such as a spinal cord injury or a traumatic brain injury. Women's health PT focuses on delivery and women's health, where a lot of things can happen in terms of providing an injury. So this is one part, how to manage them. Second is to improve performance, again in any aspect. So you need sport performance, you need an orthopedic performance, you need a cardiovascular performance. So these are the two main questions that studying biomechanics solves. And this applies to everything. So it's not that just because someone is interested in biomechanics, they have to go into ortho. Because if you see later on, as you keep on studying your chapters, this concept will apply everywhere. So now comes the main question, how to write answers in biomechanics exam. The first chapter of Norkin or the first chapter of any biomechanics book that you're referring to serves to be the foundation. So people really think that they have to really learn a lot about all the joints. But while you do have to do some part of that, I'm not saying completely no to that, you also have to understand the basic concepts. So once you understand the concepts, you can write about anything in biomechanics. And the basics of these concepts are kinematics and kinetics. Now, before I move forward, I want to tell you all something which I wish was told before when I was a student, which is types of learning. So people do feel that biomechanics is a very difficult subject, but somewhere you also have to, just a minute. Yeah. Somewhere you also have to sort of understand what your type of learning is. If I have to give an example, some people mainly learn through looking at stuff. So they need videos, they need pictures, they need stuff like that to be able to grasp. So if you're a visual learner, you ask them to read a book and learn, they'll not be able to understand any concept whatsoever. But so this is one type. They are visual learners. So identify if you're a visual learner. In today's PPT, there are a lot of pictures. Then you're watching me who's talk. See if it helps for you. Second is an audio learner. Just a minute, my screen went off. Yeah. Okay. So second is an audio learner. So some people like to listen to stuff. They cannot, like, looking at things is too much of an experience for them. They have to listen to podcasts. They have to listen to debates or conversation. Okay. Third is a person who can read and learn, who likes to read and then concept. So you read and write, etc. Fourth person is a learner who can learn by teaching or demonstration. So, okay, so you've read the topic, you've seen the topic, you've heard the topic, you're still not understanding it. Just take the book and teach it to someone. Okay. So if you're struggling with this subject, just identify after today's session where you're listening to me speak, you're seeing the pictures on the screen, you're reading some stuff on the screen, which one do you relate to the most? Okay, so that is just a small thing that I wanted to tell you, but to identify what kind of learner you are. So to learn about or write about joints in exams, you have to know about the two basic concepts, that is kinematics and kinetics. To be simply put, if you see this picture on your left, it talks everything about movement. Okay, how people move, what movement is happening, animation, which is all about movement, then the speed of movement, the position, how fast or slow it is going, whether you're running, whether you're carrying stuff, etc. So, kinematics talks everything about describing a movement, but it doesn't talk about what causes, stops, or modifies it. Kinetics, if you see this picture on the right, it talks about all the forces that are causing movement, but it will not describe about what is happening. It'll just describe how it is happening. That's the basic breakdown. Kinematics, you see the movement. Kinetics, you see the things causing the movement. That is the simplest thing you can understand. So we'll further go into a bit of kinematics and kinetics so that by the end of the webinar, you have a clear basic concept of this. So like I said before, kinematics is kinematics of human movement deals only with the movement observed. Like you think of the factors like the movement and its location in space, etc. So when you talk about kinematics, you have to talk in 5 different descriptors. One is the type of motion that's occurring. Second is the location of motion in space. So we live in a 3-dimensional space. So where in this 3-dimensional space is the motion occurring? Second is direction, whether it's forward, backward, to the sides, or up and down. These are things you have to see. Then fourth is the magnitude or quantity, or how much motion is happening. If I lift my wrist, is it only this much motion or is it going completely? Think like that. Then rate of change of motion is basically acceleration. So at what speed or velocity the motion is occurring in. Now the reason you have so many descriptors is because the body is made up of so many segments. If I have to take only the pen can move only up and down or forward and sideways. But if this pen was to be cut in half, if there was to be a joint in between, so if I make a joint now between the pen and the pen cap, there can be isolated movement here, there can be isolated movement here, and all over the place. So that's why you have so many descriptors, because the body is not one rigid structure. It is a combination of many, many structures put together and individual motion happening at all of those structures. And one of the best part of this is that's why we can move so much. That's why we can bend as much as we can. That's why we can make a complete fist. If the finger was one rod, it would be only this. But because we can close our fingers, we have as much of bending motion that we have. So we'll go through these one by one now. So in kinematics, the first descriptor, as you saw here, is the type of motion. In one type, you have a linear motion which goes completely straight. So if you see a car going from one place to another, if you see a ball rolling in a straight line, this is what you call a linear or rectilinear. Rectilinear means one. In other terms, you can also call it translatory motion. Second type of motion is a rotation. So if you see a tabletop spinning, or if you see an ice dancer who is doing her circle, that is an angular motion. So around one axis, the body moves. Now, in the human body, you don't see a completely straight motion. You also don't see a completely rotatory motion because of the different shapes of the joints. So if you see a tabletop, it is in a very specific shape to do the rotatory motion. And if you see a car, it can go straight in a row. But in the human body, you've got so many different structures, so many different shapes. So the movement that is happening every time in the human body is a curvilinear motion. If I have to give you a basketball example, this is not going straight, neither is the basketball rotating in the same place. But it will rotate in air and it will also follow a path. So that is called curvilinear. If you bend your elbow, there'll be a motion that's happening there. So the elbow is rotating and moving towards you. So any joint in the body, a pure linear, a pure rotatory motion never happens in the body. It's most of the time, it is always curvilinear. So that's the first part of motion. You have to describe what kind of motion it is. This is fairly simple to answer in exams because any motion that happens in the body is a curvilinear motion. It happens both in a straight and in a angular way. Second is the location and direction of motion in space. So like I said, we live in a three-dimensional space, which means that we can go forward, backward, sideways, and up and down. These are the three dimensions. So to understand movement in terms of research or when you're documenting certain things, you have to understand the surface of which the movement is happening and the axis around which it is happening. So we have three planes and three axes around which movement occurs. Plane is an imaginary surface in which movement occurs. Axis is an imaginary line around which movement occurs. Okay. And both of these will always be at 90 degrees. So we'll get into that right now. So if you see the first picture here, it is called the sagittal plane, which happens in the coronal axis. Sagittal plane will divide the body into left and right. So all movements that happen up and down, okay, or it's in the hands, shoulder up and down, or elbow flexion extension, knee flexion extension. So the forward backward movements, they will happen in the sagittal plane around the coronal axis. Okay, then coronal plane. Imagine a plane which is cutting your body into front and back. Okay, so this is the second plane, coronal plane, where you have the sideways movements, abduction, adduction, lateral flexion, lateral bending, all of these. Then third is transverse plane or the horizontal plane, like you can see here. So all the movements happening will be rotation. So you take your arm and you rotate it inwards and outwards. This will happen in the transverse plane. Okay. So all joints you can analyze this way, whether they are happening in a front and back motion, such as flexion and extension, whether they're happening in a sideways motion, which is abduction and adduction, or they're happening in a flat plane, which is internal and external rotation. The movements that I just mentioned are the major movements that are happening in the body, which are called osteokinematics. This is a question that comes often in the exam. They ask you what osteokinematics and arthrokinematics are. So osteokinematics is just you describing the physiological movement. That means if I ask you what are the osteokinematic movements of shoulder joint, you just say shoulder has flexion extension, abduction adduction, and internal external rotation. And then the small movements that help to cause them are arthrokinematics, which we'll go into detail sometime later. So arthrokinematics are the small adjustments such as the roll glide that happen to assist with the osteokinematics. Now, when this comes, so there are three planes and three axes. A joint which can move only in one plane and axis is called a uniaxial joint. So if you take the elbow, you can do only flexion and extension. You cannot do any other movement at the elbow. So you say that the flexion extension is happening in the sagittal plane around the coronal axis. If a joint can move in two planes, now you take the wrist for example, you can move it up and down and you can move it sideways. So up and down motion is happening in the sagittal plane and the sideways motion is happening in the transverse plane. So this is the wrist. A joint which can move in all the three planes is called a triaxial joint, which is shoulder and hip, for example. So these can, like I said before, these can move in flexion extension, they can move in abduction adduction, and they can also move in rotation. And based on this, you also tell the degrees of freedom. So because the elbow is one uniaxial, that is one axis joint, it has only 1 degree of freedom. That means it can move only in one plane. Two axis biaxial joint, it has 2 degrees of freedom. It can move in two axis and plane. And three axis, which is triaxial joint, has 3 degrees of freedom, which can move in all the three planes and axis. So this is the location and direction you can mention. So if someone says that shoulder movement is happening, so where it is happening. So flexion means a forward movement, extension means a backward movement. So this is the direction you have to say when you're analyzing a motion. So these are the other descriptors of kinematics. Next is the magnitude of motion, which is the amount of motion that's happening. Shoulder can move 5 degrees and it can move 180 degrees. So when you're talking about how much motion is happening, you have to talk in terms of range of motion. So range of motion is basically the movement happening from a starting point to the ending point. Starting point of almost all the joints seems to be around 0, unless someone has some contracture or deformity. So most of the time, so if you keep your arms completely down, it is a 0 degree position for the shoulder. And if you lift your arm completely up, it's a 180 degree motion. So you can describe the shoulder between 0 to 180. This concept is called the range of motion of any joint. So usually each joint has their normative available ranges. For example, the accepted range of motion for shoulder is between 0 to 180. The accepted range for wrist is between 0 to 90. The accepted range for elbow is 0 to 140. So whenever you talk about range, you should not just say 60 degrees. You should say from where to where. Many people may have from 0, many people don't. So they just have, if they have some injury, then their starting for wrist instead of 0 might be, let's say, 5. And then from there, they go to 90. So you have to talk about range of motion. This is something you'll have to learn. So each joint has its ranges of motion. So if you just take the shoulder, for example, you get a 180-degree flexion. You can get up to a 45-degree extension. Abduction can also go up to 180. Adduction goes back to 0. Okay. Then internal rotation is about 70 degrees and external rotation is about 90 degrees. So this is something you have to learn, but to make it easier, just perform these movements. See how much your own joints are moving for you to not have to really learn. You can just write it based on your own experiences. Okay, so with that, we summarize kinematics. You talk about the type of motion, whether it is straight, rotatory, or angular. You talk about the location in space, in which axis or plane it is happening, and the direction, whether it's happening. So even if you take a sagittal plane movement, you see if the movement is happening forward or backward. Okay, so that is location and direction. Then you talk about quantity or magnitude of motion, that is how much movement is happening, in what degree. And then you talk about the rate of change, which you don't exactly have to write in your papers because this is something you have to calculate. So let's say I ask you to take your shoulder from 0 to 180. Rate of change is the speed in which it is going, whether you finish that movement in 1 second or you finish that movement in 5 seconds. But this right now, it needs a lot of calculations. This may not be asked in your exam. Okay. So this is about kinematics. Till now, we just saw how to describe movement. We did not see whatsoever what is causing the movement or how to start it, stop it, or modify it, sort of. So kinetics, just by loose definition, is the study of forces that cause a movement or modify a movement or stop a movement. So to do anything to modify movement, you need a force. Now, there in the human body, if you take it, we can only have contact forces. For a force to sort of get applied to us, it has to come in contact with us. And whenever something comes in contact, we can either push or pull. So this shows that for a force to be applied, you need it to be in contact. You need to have two surfaces. So if I have to push, so I need both my hands to come in contact. Or if I need to pull something, my hand should be in contact with that object that I'm pulling. So force is loosely defined as a push or pull, which requires two surfaces and has to be in contact. Now, the two types of forces that act on the human body are external forces, which are acting from outside. So we have the gravitational force, which is keeping us on the ground. We have the ground reaction forces. So whatever we are putting down on the ground is getting exerted back on us. And third, any external force, like if someone pushes us, or if you're in a bus and it suddenly stops. So all these are external forces. Internal forces are the forces that are being generated from the joints. So when you're bending your elbow or you're extending the elbow, the force the muscle is applying on your bone. So pulling or pushing sort of thing. Internal forces will usually generate movement. So if you have it in your head to just make a fist right now, the internal forces will cause your fingers to bend. Okay. But if you are making a fist over a soft ball, that ball is going to exert pressure back on you, which is not going to allow a full fist. Or if you see you're walking on sand versus walking on a hard marble floor, it'll have a big difference. So that is the external forces acting on you. Now, the best way to represent these forces, you cannot keep on talking about this all the time in your exam, right? So the best way to depict these forces are through an arrow. So if you take this football here, if you have to show that the football, I'll just share my screen again. Yeah. So third, the length of the arrow will show how much force is acting. So if I yeah, so if I just make a small arrow, it means here that the force is started from the center of the football and it is moving towards the right and a very small force is acting. If I make a larger arrow, it shows that even with the same direction, a much larger force is acting. So again, here if I have to show that the ball is falling down, The arrow shows the direction. The point where I start the arrow shows where the force is being applied, and the length of the arrow shows how much force. So if anytime you have to represent forces through picture, definitely write this. So just mention what it means, what the arrow means, and just draw it wherever you want. And drawing saves a lot of time. So now we're going to talk about the forces which are acting on the human body. Internal forces, that's a big topic all by itself, where you analyze about how the muscles are acting on the body. We're going to see about gravity now, which is the biggest external force which is acting. The specialty of gravitational force is that it's a external force which is non-contact. We talked about before that any force which has to come in, which has to act on something has to come in contact. But gravity is the only one which doesn't have to. And gravity usually acts from a point in which the entire weight or mass of the body is concentrated. So if I have to take this bottle, this is the cap side which makes it heavier. Therefore, gravity would act around somewhere here, not the exact center. Okay. But if I have to take this phone, which is perfectly balanced out, gravity will act from its center because that's where the mass is concentrated. In the human body, it is approximately S2. So the second sacral vertebrae, gravity will act through the second sacral vertebrae, slightly anterior to it, considering that we almost equally divide the upper half and lower half. So the center lies around the second sacral vertebrae. So now, like we discussed before, gravitational force is always depicted with a downward arrow here. So what does it tell you? The point of the arrow is starting from S2, which shows us that the point of action is from the second sacral vertebrae. Direction of gravity is always downward. So that's why the arrowhead will point down. And the line of gravity shows the amount of gravity acting. So if you have to start gravitational force from the head, it will be a much larger line because the higher you go, the more gravity is working to pull you down. But if I start the gravity from any of these red points that you see here, the line will be much smaller because the more closer you are to the ground, the lesser gravity will act on you. Now, how is this concept useful for you? The whole concept of the line of gravity or the center of mass will tell you about a person's equilibrium. Now you know that gravity will always act from center of mass, but we don't stand like this all the time. We keep on moving, like you see in these pictures here. We go up, we go down, we stretch here and there. So the center of mass will keep on adjusting. Like if you take your hands up, the mass will move up, and the gravitational point acting also will move up. Line of gravity will change accordingly. So wherever the gravity acts from, the line will fall from there. Third concept is the base of support. So base of support is the area covered by your position. So if you see this picture here, A, if you keep your feet together, only this small square is the base of support. If you keep your feet slightly apart, the base covered is larger. So now this concept in equilibrium is that as long as your line of gravity falls within this base of support, a person will be stable. If you want right now, you can just stand. Okay, stand, keep your feet apart. Okay, then keep your feet very close and then stand on your toes. Okay, if you're feeling a little more adventurous, stand on one toe and see which one you feel the most stable in and which one you feel the most unstable in. This is because the wider your base of support, the line of gravity will fall. So even if you have like a nice shoulder with leg stance and you bend laterally, your weight is shifting to one side, but the line of gravity will still fall because you have kept a very wide stance. But same way, if you stand on your toes and then bend to one side, you will fall on that side because the line of gravity is now falling outside. So that's what you see in these pictures here. In a regular shoulder width stance, this is where the line of gravity is. When you bend forward, it moves anterior. So if you don't keep your hands here, you will tend to fall forward. But because you keep your hands here, it will create a much larger center of gravity. Then same over here. When you bend back, it's going back. So whenever you prescribe exercises to a patient, especially if you're balance training them, you always have to see their base of support. You have to give it in such a way that their line of gravity will always follow. And then as a progression to increase it, you can shorten it and challenge them. So now, how do these forces act on the body? This is where your Newton's laws come back into picture. We are going to simplify it right now. Any force that is required to initiate motion is what the Newton's first law or law of inertia talks about. any force which is required to maintain or change the speed of motion is what Newton's second law talks about, which is also called law of acceleration. And any force that react with each other is Newton's third law, or law of action and reaction. So the first law, if you can see the picture here, if this ball is just kept and no force acts on it, it will not move. That means that the ball is in a state of inertia. Inertia is the property to resist any motion. So this ball will not move unless an external force is applied on it. So as per definition, an object will remain at rest or in uniform motion unless acted upon by an external force. Okay, that's the first thing. So even if you're standing and someone has to push you, your body will not just fall the minute someone pushes you. It's because you have a property to resist that motion. So that is Newton's first law of inertia, which basically will calculate how much force is required to get a body out of its state of motion, which can be anything, whether it's the ball or the human body, etc. Second law of motion, we'll see now. In after the first law, you put the body in motion. You've got the ball rolling. The second law will see how much acceleration is happening, at what speed or what velocity it is going. And this law will calculate it. So F is equal to ma is what comes here, where acceleration is inversely proportional to mass, which means heavier the object, lesser acceleration, lighter the object, more acceleration. Take two balls, one tennis ball and one basketball, and just roll them. You'll see that the tennis ball will roll much more and much faster than the basketball, which is a heavier object. That is what the second law talks about. So first law, you see how much force is required to get something in motion. Second law, once the object is in motion, you see how much acceleration it goes through. Third law, if you imagine a wall here and you push a ball, it'll come back to you. But if you push it very lightly, it'll come back only that much. But if you just bang it against the wall, it'll come back to you in that much force. So the third law talks about action reaction. Whether how much force you put, that much force will come back. If I have to give you a real life example on this, if you take two people on wheelchairs, you're teaching them how to maneuver their wheelchair. The lighter person on a wheelchair will be able to go much faster with much less effort to move the wheelchair. Okay? But a heavier person who has more inertia will have to put much more effort to move the wheelchair, and they may or may not be as fast as the person who's lighter. So this is where you have to see the movement, how much a person is requiring force, especially when you're prescribing assistive devices such as crutches or wheelchairs. You have to see how much it takes for them to move. Okay. Now, these are the laws that are talking about motion and how it's starting and how it's manipulating. But you need someone to stop it, otherwise infinite movement will happen. So in the human body, this is called the concept of end feel. When joints move, like when you take your shoulder up, what is stopping your shoulder here? Why is it not going more back? Or when you bend your elbow, what is stopping it over here? That is the concept of end feel. So when you bend your elbow, it is your forearm muscles coming in contact with your bicep. Two muscles coming in contact with each other. This concept is called a soft end feel, where the motion is stopping because of two soft surfaces coming in contact with each other. Now, when you straighten your elbow, you cannot straighten it anymore. This is called a bony end field because the bones over here are locking with each other. They are not going to allow any movement because they lock. So similarly, when you do back extension, both the spinous processes are going to collide with each other, locking that movement. That's a bony end field. Sorry, the third one here I am meant to write firm. So the third is a firm end field. When you do wrist extension, you're not seeing a muscle on muscle. You're not seeing a bone on bone. The thing that is stopping wrist extension is a stretch to the wrist flexors. This is called a firm end field, where the movement is stopping because of capsule getting hard, or because of muscles getting stretched, or because of a tendon or ligament stopping the movement. So these are the three end fields which you can analyze for anything. So if you have to do, let's say, shoulder flexion, the movement is stopping because of the muscles of the shoulder. If you do knee extension, the movement is stopping because of the hamstring pull. Elbow extension, the movement is stopping because of two bones coming in contact. So this is something you can write for any joint, which, by logic you can understand, or you can perform it in the exam hall and write it. Yeah. So now we always have more one or more forces acting. So when you see how the forces act on the human body, if two forces are acting towards each other, they're going to cause a joint compression. So let's say someone falls from a three-story building and then sustains a fracture and comes to you. It is important to see how the fall caused the fracture. Most of the time it's because of compression, because you've got the ground also pushing up and you've got the person also falling down. Second is if there are two forces which are pulling in opposite direction, they cause tension or tensile forces or longitudinal forces. They will cause a stretching effect, which most of the time happens with muscles. If the huge pull of the muscle on a bone, that tension will can even crack the bone. Third is a shear, where you have two forces acting opposite. This is also one of the reasons for fractures, where if you have like, if you're stationary somewhere and one force comes and hits, then that can cause a fracture. Fourth is a rotational force, which is a torsion. If the torsion is going to happen in the same direction, it's going to cause a rotation. But if it happens in the opposite direction, it's going to cause a rotational twist. And last is a combination of forces. So someone can have a compression and torsion happening together, or a tension and shear happening together. So these are the most common forces that act on human joints. So it's compression, distraction, torsion, and shear. And lastly, a combination of all of these. Till now, you saw that everything is affecting the bone. None of these actually spoke about how it's going to affect the muscle. So you saw all these different forces. You saw gravity, you saw the compression, shear, etc. These never act alone. So let's say you're doing a squat. You've got a compression also acting on the muscle and the bone. You've got the gravity also, and you've got the ground also acting back up on the body. So you at one point, at least two or more will act. So whenever there are two forces acting on a human body, they're called a force couple. And the strength of rotation produced by this force couple is called the torque, which is a very important concept or question that you get in your exam. Okay, so torque is nothing but the force generated or force applied into the distance. What do you mean by that? We'll see over here. Now, this is a question that I had given to you yesterday in the terms of MCQs, in which if you have to carry something heavy, which of these elbow positions would you choose? So we're going to see how the torque is generated. Now, you must have learned in the physics concept about the position of the door handle to open or close a door. If you have to open a door and the handle was close to the hinge, you would have to require a lot of effort to do that. Therefore, they keep the door handle away. They keep it towards one end so that it becomes easy. That's because of the torque generated. With the door handle being far, you have a stronger torque as compared to the door handle being close. We'll see what that means now. So if you compare this to a door handle, this is the point around which the movement is happening in the elbow joint. So the joint line is where the point of movement is happening. And if I keep a heavy object here, okay, the perpendicular distance between this and the point around which the force is acting is this much. Okay. Now, this is at 30 degrees of elbow flexion. Now, if you go to 90 degrees of elbow flexion, again, we take the point at which the force is acting and where the force is acting. Again, there's a heavy object here. This distance you have to measure. Okay. And lastly, you go more than 90 degrees. You go to 180 degrees. Again, we take the point where the force is acting. This is a heavy object here. And we take the perpendicular distance. Yeah, this is the force that is acting. Now, out of all the three positions, this has the 90-degree position has the longest distance between the point of action and where the force is acting. Now, the longer the momentum, as you can see, torque is equal to force into the distance. So more the distance, more the torque generated. Therefore, the effort becomes much easier. So when you train your patients for strength, especially, for each joint, you have to see in which position they'll be able to do it best. Or when you're training them for their activities of daily living, for example, someone with an elbow fracture or elbow ligament sprain, is getting back to their daily routine. And part of their daily routine, if they're a student, involves carrying books, or a person who stays at home involves carrying heavy food items on their hand, you will suggest them to do it in a 90-degree elbow position, because that is the position where the momentum is greatest, the distance is greatest, and therefore the biceps will be able to generate more torque or more strength to perform this movement. So, as an answer to the yesterday's question that I put over here, as to which elbow position you'll be choosing if you have to carry something heavy on your hand in such a way that you can do it better, would be option B. It's because the distance between the point of application of force and the axis around which the force is acting is the greatest. Therefore, the greatest torque will be generated. That's a very basic thing. You have much more things like the angle of application. So here the biceps is in a particular angle. Here the angle changes. Here the angle changes. Here we are assuming that the elbow is going to be in this position, but elbow can be front also, or it can be back. So as you go more into biomechanics, you'll see how to do these calculations and create the best rehabilitation programs, especially if you're getting into sport. Okay. So with this, we complete the basics of kinematics and kinetics. If I have to show you the first slide again. In kinematics, we talk about describing movement. In kinetics, we talk about describing forces that cause the movement. Now, using this, we'll see how to write any question in your, any joint question in your exam. So again, I said, depending on the university that you're at, you will be asked a 10 or 15 mark question on, let's say, write about the shoulder complex, write about the axis and planes of the shoulder complex. I remember getting such a question with my elbow joint, the radio-ulnar joint, and I was stumped. I had no idea how to write such a 10 or 12 mark question on that. But then as I reading more, I just realized it's a very pretty simple thing. So first, you write the name of the joint. Whatever joint you're asked, you write the name. If shoulder, you have like 2, 3 joints within the shoulder complex. So you have to name that. Then you write about the type of joint. This is where you have to slightly go back into your anatomy, where you learn about the different types of joints. So whether it's a ball and socket, whether it's a saddle or a pivot or something like that. Then you talk about the articulating surface. What are the two bones making up that joint? Okay. Then, like I mentioned before about the osteokinematics and the arthrokinematics, osteokinematics is the flexion extension movement. Arthrokinematics is the minor changes or adjustments that happen in the movement to cause flexion extension. Okay, these are dependent on the concave and convex surfaces, which surface will roll, which surface will glide. So you talk about the convex surface, which is the rounded surface, and the concave surface, which is the depressed or flat surface. Then you talk about the type of motion, curvilinear motion, that happens in all the joints. Under curvilinear motions, then you talk about the osteokinematics. So if you're like, if I have to give you an example of my own exam question, which was right about the radio-ulnar joint, the osteokinematic motions are pronation and supination. Okay, these are some things you write. Then you write about axis and planes. So pronation and supination will happen in the transverse plane. Then you talk about degrees of freedom. So if you take a joint, in whichever plane, the number of planes it can move, that is a degree of freedom. Hip moves in all the 3 planes, it has 3 degrees. Elbow moves in only one plane, it has only 1 degree. Then you talk about the available range of motion. Like I mentioned before, you talk whether the joint has 0 to how many degrees. Like flexion of shoulder has 0 to 180, flexion of elbow has 0 to 140. Same goes with knee. Knee flexion is 0 to 140, and all the ranges. So how much flexion range is there, how much extension range is there, and so on. Then you talk about the end feel. So if you take the knee, when you bend your knee, the motion mostly stops because of the calf and the hamstring coming in contact. So you mentioned that the flexion movement at knee has a soft end feel, and the extension movement at knee stops because of hamstring pull. So you have that as a firm end feel. Like this, you talk about the end fields after mentioning the movements that are occurring. Then you talk about the functional open chain and closed chain. This is not part of this webinar right now, but to give you an example, for knee flexion, an open chain movement is just standing and bending your knee. Closed chain movement is going down on a squat. So open chain, you have an unrestricted movement. In a closed chain movement, the top and bottom segments are fixed. So the hip and hip and ankle are fixed in a spot. You just have to go down and come up. That's a closed chain knee movement. And lastly, this is again where your anatomy comes into picture. You have to talk about so all this till now is kinematics. The last point is kinetics. What causes a joint to move? Muscles. Muscles are the ones which generate force. Therefore, this point you talk about kinetics and write about all the different muscles acting on the joint and their movement produced. So you already wrote here about the osteokinematic movement, that is flexion, extension, etc. And the last point here, you just write about the muscles that are causing them. Like elbow, biceps causes flexion, triceps causes extension, like that. Okay, so you just write under these few points and you'll have the basic structure to write about any joint, because there's nothing more that you can write as an introduction. Then you can play around. Like if you've learned about the ligaments, if you've learned about the angle of pull, if you've learned about the angle of action, you can just add on to it. But you write these basic points, you'll be able to get some marks at least. You don't have to leave the question altogether. Okay, so now as an activity, I would like you all to take a paper and pen and just write about we'll do it together. So we'll write about the hip joint. Now you see how long that answer gets. So you'll only come to know that how much marks you'll actually get if it was a 15-mark question. So just take a paper and pen and we'll write about it. And you also have to think. Obviously, I'll be dictating here, but you also have to think. So first thing here, I'll just take my pen. Yeah. Okay, so you've got a question in your exam. That is, write an introduction about the hip joint or write about the hip joint for 15 marks. So here's the basic thing. You name the joint. So usually it's called okay, this is difficult. I'll just, 1 minute. Yeah. So here you just name the joint, which is the hip complex. Okay, that's the first thing. Second is you draw the joint. Yeah. So if you go to the Prakara Instagram app or their website, you'll see that they teach you how to effectively draw joint, because sometimes people really struggle with that, but drawing can really get you ahead. So just go through their tutorials to see how you can draw joints. So hip joint is made from the acetabulum of the pelvis. Okay. Yeah. And the femur. So you've got the femur here. I hope you all are doing this with me. This is an activity for you all. Yeah, that's a very computerized loose version that I could do here. So then you label this. You label that this is the acetabulum and you label that this is the head of the femur, which forms the hip joint. Then third, you talk about the type of joint is this. Again, this is where you have to refresh your anatomy a bit. Hip, this is a ball and socket joint. Yeah, type of joint is ball and socket. Okay. Then next you again talk about the articulating surfaces, which is the acetabulum and the femur. Then you talk about which is the concave convex surface. So as you can see here, the femur head is round. So that is the convex surface. And you see that the acetabulum is having a slight depression here, which is the concave surface. Okay. Then type of motion occurring in a joint, you write it as a curvilinear motion. Then osteokinematic motion. So hip can go into flexion, it can go into extension, it can do abduction, then it can do adduction and internal and external rotation. Okay, I'm just going to make this small so that rest of this is visible. Okay, so you've spoken about this. Then axis and planes of the joint. So flexion extension, it is a forward backward movement. This happens in the sagittal plane. So like I told you, sagittal plane makes the body into left and right. So it is something that you see from the side. So sagittal plane and coronal axis. Okay. Then you have the abduction, adduction, which is happening in the frontal plane. So abduction, adduction are sideways movements, which you see from the front. So you got it as coronal plane and sagittal axis. And lastly, you've got rotation. So hip rotates inwards and outwards. So internal or medial and external, which is lateral, you have it in the horizontal plane or transverse plane. They are interchangeable names. And vertical axis. Okay. So you've written this point. Now that you know that hip can move in 3 planes, you write the degree of freedom as 3, the next point. And available range of motion. So hip flexion can happen up to 140 degree or 160 depending on someone's muscle bulk. So someone who has a very large muscle bulk will have less, and someone who has a little less muscle bulk will have more. So let's say take an average one. So you always write in a range. So 0 to 150. So this teacher who's correcting your paper will know that you're starting from 0 and then going from 150. Then extension range in the hip, you've got 0 degrees to 15 degrees. The hip can only go 15 degree backward. Then you've got the abduction range, which is 0 to 45. When you take your hip to the side. Now this is completely dependent on someone. This is the normal, obviously. Someone who is a gymnast or a yoga person, they'll have much more than this, but this is what the average person has. Adduction, you go from 45 back to 0. You have adduction which can go more, but that is again subjective. But right now you write 45 to 0. Then rotations of the hip are 0 to 45 degrees. So it can rotate inward 45, outward 45 from the neutral position. Okay, I'll make this also small now so that you can see the rest of the stuff. Then you talk about end feel. So hip flexion most of the time has a soft end feel. So if you take your knee to your chest, the motion will stop because of your thigh coming in contact with your abdomen. Or if someone has so this is soft or firm. If someone has very less muscle bulk, it will stop because of the posterior muscles getting stretched. Okay. Extension again would be soft or firm depending on someone's muscle composition. And most of the movements around the hip are soft or firm and feel. Okay. So abduction, if you see, you immediately start feeling a stretch on your inner thigh. So abduction is a firm and feel. Adduction, again soft because it stops because of the two thighs coming in contact together. And internal and external rotation are again firm. It's because internal rotation gets stopped because of a pull on the external rotator. Yeah. Then functional open chain and closed chain movements of the hip. If you're talking about hip flexion, open chain movements is a straight leg raise. If you're just lying down on your bed and you lift your leg up, it is a straight leg raise. It's a completely uninhabited, sorry, not uninhabited. It is a completely unrestricted position of hip flexion. But if you squat down, it is a closed chain movement. It is a restricted movement of hip flexion. You need the ankle and knee to be in one place for the hip to move down. Okay. So you write functional open chain and closed chain. Well, 1 or 2 examples are fine. You don't have to write about everything. Then lastly, kinetics. You talk about the muscle of the hip and the force they are producing. So flexion is caused by hip flexors, which is the iliopsoas, which is the piriformis, and the rectus femoris. Okay. Then extension you would write as to be caused by the gluteus maximus and a part of the hamstrings. Okay. Then abduction. Again, majorly caused by the gluteus maximus and medius. Okay. Adduction would be by the large adductor muscles, adductor composite. You have the adductor magnus brevis longus. So these are the ones which will cause the adduction. Okay. Then internal rotation will again be caused by the adductor group, and external rotation by the sartorius. Then you have the obturator group of muscles. And you also have the ones on the side. So to some extent, gluteus will also cause external rotation. Okay, now if you've been writing down all of this, see how long it has become. This will already give you a nice structure to writing your exam paper. Okay, so we did this just by understanding concepts of kinematics and kinetics. Now there's a lot more that goes on around a joint. So if you really start studying, you can add up to this and really create a very long answer while also understanding the topic well. Okay, so lastly, I want to close with the different reference book. I know that Cynthia Norkin is the most commonly given book. So there are a lot of books for biomechanics, especially in your undergraduate level. Cynthia Norkin will talk about the joint biomechanics in detail. It's one of the best books for joint biomechanics, and it's also a great book for gait and posture. Joseph Hamill book talks about the skeletal and muscular structures. So how the structure of a skeleton or the structure of the muscular system can, sorry, excuse me, how the structure of the skeletal or muscular systems can influence movement. Carol Otis talks about the pathomechanics. So you learn all these normal biomechanics that happens in a joint, like how much movement is happening, what forces, but what if there is excess forces? Or what if there is not enough movement happening, which should happen? So Carol Otis talks about this. So if, it will be very useful for you to learn about injury and rehabilitation. Diane Knudsen biomechanics books talks about in-depth mechanics. So you learn about all the formulae of force, velocity, acceleration, etc. And anyone who wants to get into sports later, sports biomechanics, sports analysis, this is a very useful book. We'll truly talk about how to apply physics to the human body, including how to do all the calculations, how to interpret graphs, etc. And lastly is the Brunstrom book. It has a little bit of everything, and it simplifies the concepts basically. So for some people, Cynthia Norkin may be little difficult to follow. They can go to Brunstrom, which also talks. So these are the 5 basic ones. You also have more, which can be used at a more master's level. But these are the overall reference books. And with that, I end today's webinar. I hope you found it to be useful to understand the very basics of it and how to attempt any question that comes to your exam. So you have a WhatsApp group. You can definitely, if you have done this activity with me right now to write about the hip joint, please take pictures and share it on the WhatsApp group so I can see that what you have written. And you can maybe even try it for any joint. So take any joint, even the difficult ones like radio ulnar joint or the subtalar joint, and try to attempt writing that in such a format and send it on the WhatsApp group. So I'll be seeing them if you want. And definitely head over to the website and Instagram of Prakara to see more about diagram drawing or little tips and tricks here and there. Okay. Okay then. And any questions, leave it in the comments below. I'll be happy to answer them. So until next time, we'll see you. Okay. Bye.